Hey, what's up? It's your old pal, Mr. Cook, and we're going to go through the test review, problem by problem, all the way up until the graphing part, so up until number 20 and number 21. All right, so I'm probably going to do this one by sections, maybe 5 minutes at a time. So we're going to start off with state whether the function is a polynomial or not. So the only time that it's not going to be a polynomial is if you see a variable that's in the denominator of a fraction. So you can have whatever you want up top in the numerator, but in the denominator you cannot have a variable. So this is not a function right here. And another thing is if you have a variable underneath a square root. Doesn't matter what else is going on around it or inside of it. If the variable is inside the square root, it is not a polynomial. So these are the two cases where you don't have a polynomial. And as you can see, for number 2, we have a variable in the denominator. So that means that this is not a polynomial. And we can just circle the n to show that we know that the reason that that's the case is because we have a variable in the denominator. Now this one, number 1, is a polynomial. So since it is, we have to state its degree and also the number of terms that it has. All right, so the degree on a polynomial is the biggest power on any of the exponents. So for this 9n to the third minus 7n, that 7n actually is a 7n to the first power. So the biggest power that we have is this 3, so that's the degree. The degree equals 3, and that's all you have to write for it. Now for the terms, terms are always going to be whole values or monomials that are separated by addition and subtraction. So in this case, we have a minus sign right here, and we have 2 terms separated between them, so that means that we have 2 terms. And we call this a binomial. I'm sure if you just wrote down that you have 2 terms there, since that's what it's asking about, to find the number of terms, that would be good enough for this response here. So remember to be able to spot when you don't have a polynomial, and then also what the degree is, it's the biggest power, and then also the number of terms, the stuff that's separated by addition or subtraction or plus or minus signs. So just to kind of piggyback on that with this, we're not going to divide yet, but if I'm looking at this polynomial right here in parentheses, it has 1, 2, 3, 4, 5 terms. So this one would have 5 terms because they're all separated by addition. And then the biggest power of all these is 4, so it's degree 4. So just to show that skill for a different polynomial. But we are going to divide this real quick, and the way that we're going to divide is by using synthetic division. So I actually put together a whole worksheet video on synthetic division in, where was it, 2.2. So if you want, look at the 2.2 video. I go through a bunch of examples of synthetic division, so if you're still a little bit, if you're struggling a little bit with it, please go to that video first so you can see a bunch of examples worked out in much more detail as well. And by the way, this stuff from the first 2 problems can be found in 2.1. You see it has the exact same description. So if you want 3 other examples of these, and I think I might even go over more of them, I don't know, but go to the 2.1 video for that. So yeah, maybe that's what I'll start doing also. I'll write down the section that you can find this in. So this stuff can be found in 2.1. So if you want to reference more examples, go to the 2.1 video. This one is 2.2 on synthetic division. And just division in general, so make sure to go to that one if you need some help with synthetic division. So what we do for synthetic division is set the divisor equal to 0. So in that case, if v plus 10 equals 0, we subtract 10 from both sides and get v equals negative 10. That's the number that's going to go in the corner right there. And then we list off all the coefficients. So we have 1v to the 4th power, 16v to the 3rd power, 64v to the 2nd power, 46v to the 1st power, and then 70 is our constant. Underneath the constant, we put our remainder box. Okay, so the first number always drops down. 1 times negative 10 is negative 10. 16 minus 10 is 6. 6 times negative 10 is negative 60. 64 minus 60 is 4. 4 times negative 10 is negative 40. 46 minus 40 is 6. 6 times negative 10 is negative 60, and then we get 10 for our remainder. Now, if we want to write this up as a polynomial, for the quotient of this, when we divide all this stuff out, here's how we write it up. The first number outside of the remainder box is the constant, and then the rest of these are coefficients. This is a coefficient on x, and then it goes up x squared, and then x to the 3rd. So we have 1x to the 3rd plus 6x squared plus 4x plus the constant 6 plus, and then we use our remainder, which is 10, that goes in the numerator, And then in the denominator it goes whatever we were dividing out. So in this case we were using v plus 10, but I already changed it to x's, so let's just keep it as x plus 10 for that. Okay, so I just changed the variable there, that's all. And I'm going to keep that as a common theme also. I'm just going to use x for the most part, so I hope that doesn't bother you too much or offend you. If it does, you know what? If it offends you, go find another video somewhere else. Just turn off the video and go away. I'm just kidding, but whatever. Okay, so m minus 7, set that equal to 0 and solve. Add 7 to both sides and you get 7. So 7 is the number that goes in the corner. And then you have 1m to the 4th power, so a 1 goes in front there. Negative 7m to the 3rd power, so put negative 7 up there. And then notice that we don't have an m to the 2nd power. See, where's the m to the 2nd power there? I don't know. Since it's not on there, then that means that we assume that there are 0 m squares on there. So we put 0 for its placeholder. That's what we call that value. If there's a 0 there, and then we have negative 8m to the 1st, and then plus 52, or 52, just the end. I don't know why I put that plus there. Okay, so we do the same thing, synthetic division algorithm, and the remainder goes under the 52. So here we go. 1 times 7 is 7, 7 minus 7 is 0, 0 times 7 is 0, 0 plus 0 is 0. 0 times 7 is 0, negative 8 plus 0 is negative 8. Negative 8 times 7 is a negative 56. And then 52 minus 56 is negative 4. So we have a remainder of 4. So we're going to write it up as a polynomial quotient again. So we have our constant value, x squared, and x to the 3rd. The only one that actually has a term here with a coefficient is the 1 x to the 3rd. So we have 1 x to the 3rd, and then our constant. Because these zeros, they don't count. You don't have to write those in there. So we're just going to write minus 8 at the end, and then write up our remainder, which is negative 4, which goes in the top, and then in the bottom it's going to be x minus 7. And just remember, I'm changing all the variables to x to make it a lot easier on myself. Okay, so that's it for the first 4 problems, and that's it for this video as well. Go ahead and take a look at the next video, which we're going to probably finish off the rest of this page here.